Hey there students, welcome to the review video for the practice exam. I'm going to be talking about each of the key concepts that's addressed in each of the questions, and as always, if you need to jump to a particular question, just use the time codes in the description. The format is going to be really similar to other exams that you've done in this exam week. You'll have 10 minutes working time, 90 minutes, not the other way around, 10 minutes reading time and 90 minutes of working time. And you are allowed to bring in 2 pages front and back of notes, so 2 A4 pages of notes. Just make sure you don't have anything stuck to it, no whiteout on it, just to make sure that that fits the regulations that we've set up. And I'll talk a little bit about what could go in your page of notes. And similarly, it's really important that you bring your own calculator. If you bring your own calculator, it's a calculator that you're familiar with and one that you know how to use. If you end up having to borrow one on the day, there's no guarantee that it's going to be working in the way that you expect it to. And once you start the exam, we can't really help you with showing you how to use the calculator. So if you're using one on that you know, it's going to be a big advantage for you. A couple of tips for the actual exam itself. Have the intention of going through it multiple times. You are kind of like on a quest to find as many marks as you can. And that might mean that if you can't fully answer a question, you might get a mark for writing down a formula or writing down a bit of working out or drawing a diagram. So we want to be trying to collect as many of those marks as we can. But really importantly, as soon as we hit a question that we can't answer, the best thing that you can do is move on. Like give it a couple of minutes, and if you're still stuck, you just need to keep going. Now, there's 2 things. It lets you move on to the questions that you can answer, which not only gives you the marks for those questions, but it increases your sense of confidence as well. But it also lets your brain work on those other questions in the background, and then by the time you come back to them, you might have had a flash of inspiration of some kind. Okay, now let's get right into it. Now, for the first skill that we've got to cover is Pythagoras. There's 3 things we need to be able to do for this exam. We need to be able to find the length of the longest side of a right-angled triangle. We need to be able to find the length of a shorter side of a right-angled triangle, and then take this information and apply it to practical problems as well. Now, you might have seen this video that I've helpfully hidden off to the side. Now, here we've got a right-angled triangle on a big wheel. And there's both of the 2 shorter sides have been squared, and the area of that is represented with the water. And what we see is when we tip that upside down, those 2 side lengths squared add up to the same as the longest side length squared, and that works every single time for right-angled triangles. And just to show there's no witchcraft, it works backwards as well. So the square of the longest side is going to be equal to the square of the 2 shorter sides added together. So the way that you'll usually see this written down is like this. Sorry if the pen goes a bit wobbly, it's not a perfect stylus. So we call the 2 shorter sides A and B and the longest side C. We see that written like this: A squared plus B squared equals C squared. And like I say, this works for every single right-angled triangle ever. So if we consider this first triangle that we've got there, we don't know what side length C is, but we want to find out what it is. So what you could do for this one, I'm going to write it slightly differently. I'm going to say C squared equals A squared plus B squared. That's fine. It's the same as the rule I wrote up here. I've just written it in a different order because C is the thing that I'm looking for in it. I just prefer doing it that way. Anyway, so now what I'm going to do, I'm going to take the lengths of my 2 shorter sides, so 9 and 12, and put them into my equation. Doesn't matter which one is A and which one is B because we're adding them together, so the order in which we add them doesn't matter. Like 9 squared plus 12 squared would be the same as 12 squared plus 9 squared, so that's fine. Anyway, so then we found out that C squared is going to be equal to, on your calculator, 9 to the power 2, 9 squared plus 12 squared. And that's equal to 225. But that's great. We found out what the longest side squared is, but we want to find out what the actual side length is, not the length of that squared. And what you might recall is that if I just pick a random number, 3 to the power 2 equals 9. But then if we found the square root of 9, finding the square root is saying, well, what number multiplied by itself is going to give me the number I'm finding the square root of. So in this instance, the square root of 9 is 3. So that's going to get us back to the original number. So in this case, if something squared is 225, we can find out what the something is by finding the square root of 225. And on this particular calculator, square root of, I'm going to say square root of answer. I'm using the previous answer that I used to find the square root. Or if you prefer, you can say square root of 225. That's fine too. And that gives me 15. Okay, so that's an example of finding the longest side length. So that's skill number 1 ticked off. So something like that might be a sensible example to have in your sheet of notes. Okay, this second question here is an example of finding the shorter side. Now, if a squared plus b squared equals c squared, what we've got to do here is say, well, we're not finding the longest side anymore. We're finding one of the 2 shorter sides. So I've got to write it a little bit differently. So a squared plus b squared equals c squared. If I arrange that a little bit, I'll say a squared is going to be the same as c squared take away b squared. So yeah, it's the same formula. I've just written it in a slightly different order. In this case, the order that we subtract is important. We want to do hypotenuse take whatever the shorter side is. Okay. If I just move this to the side slightly, so a squared is equal to c squared take b squared. So longest side is 26. One of the other shorter sides, well, the other shorter side is 24 squared. So then on my calculator, I'd be punching it in like this: 26 squared take away 24 squared. Oh, 24 squared equals 100. And then similarly to last time, if something squared is 100, the something is going to be the square root of 100, which is going to be, we don't need the calculator for this, will be 10. And a good way to check that you've got these answers right, by the way, is if you're looking for one of the shorter sides, we're going to need an answer here that's less than the longest side, 26, but not like an amount shorter that doesn't make sense. So looking at this particular question, 26, 24, and 10 seem like pretty sensible lengths for a right angle triangle. Anyway, so that's an example of how we find the shorter side. It's probably a good one for your example, for your sheet of notes rather. Now we've got 2 worded questions here. And I'm going to answer number 4. And if you want to try number 5 or any of the other questions, I'm not going to answer literally every question, by the way. I'm just going to show you how to do each type of question. But for these worded questions, there's a couple of things that we've got to do. So we've got to try and imagine what the actual situation is. So in this case, we've got a 3-meter wooden plank is supporting a billboard that is 2 meters high. What's the distance of the plank from the base of the billboard? Okay. So for these questions, if you need to use Pythagoras to solve a problem, you need to find a right angle triangle somewhere in this problem. So we'll start off with the billboard. That's probably easiest. I'm going to draw it from the side because that's probably where our right angle triangle is going to be. So our billboard is 2 meters high. So yeah, 2 meters. And we are holding it up with a 3-meter wooden plank. So I reckon that wooden plank is going to go there. That's 3 meters. Cool. And then we want to find out what is the distance of the plank from the base of the board. That's the mystery length there. So I reckon the right angle triangle that we can use to help us here is going to look a little bit like this. We've got a longest side of 3. We've got a 3 meters. We've got a shorter side here of 2 meters, and we want to find out what this length there is. So we're finding the shorter side of the right angle triangle. So real quick, I'm going to do those steps again. A squared is going to be equal to 3 squared take 2 squared. On your calculator, that'd be 9 take 4, which means it's 5. And then a is going to be the square root of 5. And because 5 is not a square number, it's going to give us a answer involving lots of decimals. So the answer the calculator gives us is 2.236. We want to round that to 1 decimal place. So let's look at the 2. The next digit is a 3, so we're not going to round it up, we're going to round down. And our answer is 2.2 meters. And a quick look at the rest of the diagram. The plank thing is 3 meters, the billboard is 2 meters, so the distance of 2.2 meters, that makes sense. So yeah, so for these sorts of questions, where it's saying use Pythagoras to find what the answer to the problem or whatever is, that's pretty much your first thought. It's like, where here is the right angle triangle? Okay, skill set number 2 is about percentages. Number 1 is converting between decimals, fractions, and percentages. Number 2 is increasing and decreasing amounts by percentages. Now, let's start here. So 37%. Percent means out of 100. So 37% means 37 out of every 100. If we write that as a fraction, we can just say 37 divided by 100. Done. That's pretty cool. And then to get from a percentage to a decimal, in the same way that for a fraction we've put it over 100, we can do the same for a decimal where we're just going to say 37 divided by 100. You can use your calculator if you like, but this would be 0.37. Now, similarly, here we've got 0.1. If we want to make that into a percentage, it would be sensible for us to times that by 100, which would give us 10%. Although, once you've done a few of these, it tends to become pretty automatic. So something like 0.1 as a percentage, you'll be going 10% really quickly. And then similarly, 10% as a fraction would be 10 out of 100, which would be the same as 1 over 10. Easy peasy. The next one is 3 over 10. And I think we'll do this one and then we'll do the whole thing. So 3 over 10, I'll do 3 divided by 10 to give me the decimal. That would be 0.3. Times that by 100 gives me the percentage, so that'd be 30%. And then lastly, 34%, we'll just do that because it's there. 34 out of 100. And I'll show you a neat trick actually. On your calculator, you can go 34, and then if I can find the fraction button, I can do that over 100, and that will use the calculator to help you simplify your answer. You don't always have to simplify your answer, but if the question asks that you do, that's a nice way to help you. And then as a percentage, 34 divided by 100 would be 0.34. So yeah, these are pretty straightforward. I think I'm hoping that this will be some pretty easy marks. But as always, if you need any extra assistance, we've got a couple of days before we go. Okay, so that's number 1. And then the next one is increase and decrease amounts by a percentage. I'm not going to do literally all of these again, but the easiest way to find a percentage, if you've got the use of your calculator, say here where we've got 30% of 500, what we want to do is start by taking this 30% and writing it as a decimal. So using what we've learned before, 30% means 30 out of 100, which as a decimal is 0.3. Now, if I'm finding 30% of 500, if I times that 0.3 by 500, I'll do this on my calculator just to show you how it works. 0.3 times 500, that gives me 150. That's the easiest way, if you've got access to your calculator, of finding the percentage of a number. If we were doing 20% of 60, it'd be 0.2 times 60. If it was 9% of 200, 9 divided by 100 is 0.09. So 0.09 times 200. So that's the easiest way to do it. Now, with this in mind, if we think of these discount sort of questions, so we've got a $600 TV that's been discounted by 20%. There's 2 ways that we can do this. What we can do is find 20% of 600 first. So 0.2 times 600 is 120, but that's the amount that the discount is. So we've got to take that away from the actual amount. So it's a $600 TV. We've reduced it by 20%, which is $120, which gives us 480 buckaroonies. The other way that you can do it, and you just pick the way that works for you, is that if we've discounted something by 20%, it means that there's going to be 80% left over. As in 100% take 20% equals 80%. So the other way that you can do it is just find 80% of the number. And you do that by going 0.8 times 600. which is something, all right. I wonder what it could be. Oh, same answer. That's pretty handy. So yeah, it doesn't matter which way that you do it. You can either find what the discount is and then take it away, or you can say 20% taken off is the same as finding 80%. So yeah, whatever works best for you. And then we'll do one more of these. If we are marking something up by 30%, so let's do our pink poster, 30% of 80, so 0.3 times 80 is 24. And then if we add 24 onto the 80, that gives us $104. The other way that we can do it is think, well, if I'm increasing the value of something by 30%, I'm doing 100%, so the original value, plus another 30%, which as a decimal would be 1.3. So timesing something by 1 keeps the original number, and then the 0.3 adds on the extra 30%. So we could do it like this instead, 1.3 times 80. And just to prove I'm not a liar on the calculator, 1.3 times 80 gives us 104, which is the same answer. So yeah, similar to the other question, it doesn't matter which way you do it, but if you can either find the percentage, the amount that you're marking it up by, or add it on, or figure it out as, you know, an extra percentage that you want on top of it. Okay, now we're on to area. Now, there's a few different skills for this one. Finding the area of a circle using pi r squared, finding the area of shapes that involve parts, circles, and then applying that to practical problems. Okay, the way that we find the area of a circle is pi times the radius squared, which for this one, so on this particular calculator, shift and this button gives me pi. Radius for this one is 3, and 3 to the power 2, multiply that through, gives me 28, how many decimal places do I need? 2, 28.27 centimeters squared. Done. Now, for these sorts of questions down here, if you're finding the area of quadrants and semicircles, what we've got to do is say, we'll say for this first one here, the area is going to be given by, well, that's a quarter circle, and it has a radius of 2. So I'd need to do pi times 2 squared, but because it's the quarter of a circle with a radius of 2, I'd have to divide my answer by 4. So on the calculator, pi times 2 squared divided by 4, which would be 3.14. That's neat. Centimeters squared. This next one here has an extra level of trickery. So we've got a semicircle, so it's half a circle, but this time we're given the diameter. That's the distance between, or going through the middle in a straight line across the whole thing. So we've actually got to use 5 because the diameter, the radius is half the diameter, and this time divide it by 2. You can pop that in your calculator and check it on the answer sheet, but essentially you're thinking, all right, well, what is the area of, oh, new password soon. What is the radius of the circle and what proportion of a circle is it? So they're the two big questions for that one. More for your sheets of notes, I would imagine. And then what you might have to do is something like these questions here, which is finding the area of composite shapes that have more than one shape as a part of it, and they'll include circles as well. So that first one there, the area, and what might actually help you is you draw yourself a little diagram that shows you what shapes make up this composite shape. So we've got a square and we've got a semicircle for that shape. Then what we want to do is find the area of each of those. We can find the area of a square, it's, you know, length times width or base times height or whatever. So 5 times 5. And we know that they're the same because we've got those little markers on like that. That's how we know it's a square straight away. And then similarly for that semicircle, if that distance is 5, the radius is going to be half of that. So 2.5. So we'd need to do pi times 2.5 squared divided by 2, because it's half a circle. And again, for a question like this, if we think about it in terms of finding as many marks as we possibly can, there's probably 1 mark for the actual correct answer. So then, well, is it a mark for splitting it up into 2 shapes? A mark each for finding the area of those shapes correctly, and then 1 for the answer? Maybe something like that. So yeah, even if you're not totally sure about finding the area of the semicircle or whatever, if you can draw yourself a little diagram and find the area of what you can, I think that would help. But again, more examples for your sheet of notes there. Right, next one, we're going to find the circumference of a circle using the formulas given. We're going to find the perimeter of shapes that are given there and then apply that to practical problems. Actually, I don't think I have any practical problems on this one, but that's something that you can investigate as part of your own study. Now, for circumference, there's two ways that we can do it. We can either do, if we're given the radius, we do 2 times pi times the radius. 2 times pi times the radius, which for this one would give us 12.57. And for these ones here, the other way that we can find the circumference is pi times the diameter. Because if we're not doing, if we need the radius, we've got to multiply by 2. If we're using the diameter, we don't. So yeah, it's more about picking which is the right formula for each of these questions. Gives us the same. That's pretty cool. I guess that makes sense. So a radius of 4 is the same as a diameter. No, a diameter of 4 is the same as a radius of 2. Okay, and then for these semicircles, what you could do is give yourself a little diagram like we did for some of the previous questions. So the perimeter of this shape is going to be the straight line at the top plus the curved length just there. So if you imagine starting here, let's say, if we walked around the edge of the shape, if we did something like this, that would send us all the way around. So we've got to add all of those lengths together. The straight line is easy. That's 25. That's given in the diagram. And then for the half circle, we'd need to use our formula for circumference. So I'm going to go pi times the diameter, pi times 25. Then I'm going to half it because it's half a circle. And then doing that, 25 plus pi times 25 divided by 2 should give us 64.27. Didn't say, yeah, to 2 decimal places. What are the units? Centimeters. Okay, so yeah, that's the way to think of those ones. You can say perimeter is the distance all the way around the outside. So what lengths do I need to find the length of? Okay, volume. So on to the skills checklist for volume. If we think about the skills that we need to find the volume of prisms and cylinders using this formula. So volume is equal to area of the cross-section times the height of the shape. Okay, the cross-section is the shape that's the same all the way through. So if we did like a cut anywhere through, we'd get that same, we'd get a shape with the same area and dimensions all the way through. So for this triangular prism, it's that triangle that would be the same cross-section all the way through. And then the height isn't literally how tall it is, it's just whatever the other length is going like into the whatever dimension we're going. Sometimes it's going to be tall, sometimes it might be going into the page or something like that. So for this prism at the top here, if we're finding the volume of the shape, we'd need to, of the object rather, we'd need to find the area of the triangle. Area of a triangle is base times height divided by 2. And then we'd multiply that by the height, which is 10 of the shape. So that's going to give me the area of this, multiply it by the height, and then that will give me the volume. See if I can do that in my head. 4 times 5 is 40, times 10 is 400 centimeters cubed this time. Units obviously quite important. Now, if we were doing this for a cylinder, the formula we use is exactly the same. So it's area of the cross-section times the height. But in this case, the cross-section is a circle. So area of a circle is pi times the radius squared, so pi times 5 squared. And then the height is going to be 10 for this particular cylinder. So multiplying that by 10, pi times 5 squared times 10 gives us 785.40 meters cubed. Big boy, that's a big container. All right, let's keep going. Right, how many things have we got to go now? Linear graphs, solving, probability, box plots. Okay, I'm just trying to see if I can finish this before we do our staff meetings today. I think I'll be okay. That should be all right. No, for linear graphs, we want to, it's two things you need to be able to do. And these are complete a table of values and using those to plot a graph, and then finding a rule from a table of values. So this is the first one that's just here. It's not the best graph for this, unfortunately, but we'll do our best. Now, this gives us the rule that we're going to try and follow. So we need to find all the y values, and they are going to be given by taking whatever our x value for that is and timesing it by 2, and then adding 3 to the result. Easiest place to start is always at 0. So I'm going to start here at 0. Now, 2 times 0 is 0. Add 3 to that gives us 3. First one is done. Let's move on to x equals 1. 2 times 1 is 2, plus 3 equals 5. Cool. Next one, 2 times 2 is 4, plus 3 equals 7. And you'll notice at this point that there's a pattern that starts to emerge. We're increasing by 2 every time, and that's the same as whatever we're multiplying x by in the equation. So you can figure out the rest manually if you want to, or you can just count down by 2 for each of them. So 3 going to here, if I take 2 from that will give me 1, and then taking 2 away again gives me -1. Okay, I'm reluctant to actually draw these on the graph, but maybe I'll try it for this first one and we'll leave it for the other one. So on the actual exam, you'll be given a Cartesian plane that's already labeled, so don't stress too much about that. But let's say that we had 1, 2, 3, and then this one would have to be, let's just use the same scale actually, because that's what's on the exam, and I'll just go a little bit off the page. Going in the other direction, -1, -2, -3. Going this way, -1, -2, -3. You won't have to do this on the exam though. But the way that you plot your coordinates, so when x is 0, y is 3, so go across to 0 and up to 3, put a dot there. Across to 1 and up to 5. Again, on the exam, you won't have to go off the page like this. Or maybe, who knows. And then here, we're going to go across to -1 and up to 1, across to -1 down to -2 down to -1. And you should use a ruler for yours. If I can get mine working, I'll use it. Come on, ruler. There we go. Okay, so we want a nice straight line for this one. These rulers aren't perfect on OneNote. They don't have like a totally, fluid way of doing it. But you should have something like that. Because it's a linear graph, it should be a straight line. Okay, no, we'll just do the table of values for this next one. So what we want to do is find our y values with this rule. So it's -2 times x plus 6. It's a bit of a different one this time. Let's again start at 0. -2 times 0, still 0. And then plus 6 is going to be 6. No, -2 times 1 is -2. Plus 6 is +4. -2 times 2 is -4. Plus 6 is 2. No, we've got the same pattern that we had last time. We're decreasing by 2 each time, and that's the same as our coefficient for x there as well. So similarly for the rest of the table, instead of decreasing by 2, going from left to right, if I'm going back the other way, I can just keep adding 2. So as long as the pattern stays consistent, that's fine. Now, finding the rule from a table of values. Okay, let's think about the rules that we just did. We want to see how much it's increasing or decreasing by. So this one is going up by 2 each time. So we know it has to be something to do with y equals 2 times x. Cool. Now we also need to determine what we need to add or subtract to make the rule work. And again, the easiest place to do that is here at x equals 0. Because 2 times 0 is 0. What do I need to add on to make 4? I need to add on 4. So for these rules, you'll need 2 things. You'll need x multiplied by something, and then you'll need to, which could be positive or negative, and then you'll need to add or subtract something else as well. Let's try that for the next one. This is decreasing by 3 each time. So it's going to be y equals -3 times x. Again, we'll check here to see what we need to add or subtract to make the rule make sense, and it looks like we're going to add on 2. And by the way, you can just plug any of the numbers in to see if it fits the rule. We do here, for example, 3 times -1 is -3. Add 2 gives us -1. So that works. Okay, I'm not going to spend a heap of time on solving, but you've got 2 skills that you need to do for this. Number 1 is solving a 1-step equation. Number 2 is solving a 2-step equation. 1-step equations are the easier ones. So this one, 2a equals 12, means 2 times something equals 12. When we see that word solve, we want to end up with an answer of a equals something, or b equals something, or c equals something, whatever it is that we are looking for. Okay, so for this one, if 2 times something equals 12, opposite of that is going to be of multiplying by 2 is going to be to divide by 2. So that's how we would reverse that one. Similarly for question 2 here, if something plus 4 is 7, we can reverse the plus 4 by taking 4 away, which would give us 13. Okay, probably don't need to spend a heap of time on those. You can check the exam solutions if you need it. The ones that are a little trickier are these 2-step ones. So the way that we can think about this is think, well, what has happened to our variable? Like, in what order has it had operations applied to it? So for this first one, it's 3 times a plus 2, which means we've started with a. It was multiplied by 3 to give us 3a. And then it had 2 added onto it to give us 3a plus 2. Now, if we think of it like this, let's reverse those steps with the equation that's given. Let's start by we're going to reverse this plus 2. We're going to go back this way now, reversing them in reverse order. So we're going to take that 2 away first, which gives us 12. Now I've got a nice easy 1-stepper. 3a divided by 3 is just a, and then 12 divided by 3 would give me 4. So that's the way to approach each of these. You think, what operations have been performed on this variable, and how can I reverse that? Let's think of this. We won't do all of these again, but this one, we start off with b, then 4 is taken away, and then the result is divided by 2. To give me b, or take 4 over 2 like that. So yeah, the way that we would reverse that is to go back this way and then perform the reverse operations. So let's start by reversing the divide by 2, which is to multiply by 2. And then let's reverse the taking 4 by adding 4, which gives us 10. And again, you can just try this number in the equation to check your answer. 10, take 4 is 6. 6 divided by 2 equals 3. So you know it works. And for the other ones, you can check the exam solutions. Okay, we're getting towards the end now. So for our skills checklist for probability, I'm hoping that this is the easiest one because we did it the most recently. But we did complete and interpret a two-way table, complete and interpret a Venn diagram, and find probabilities from a two-way table. Okay, let's have a look at this one. All right, we've got let's do a Venn diagram first. That's not the best, but it's okay. So we've got to have the box around the outside, which is going to contain everything. So make sure that you draw that. We've got a class of 30 students. Let's start off straight away by putting what it should add up to. U stands for universal set, if you're interested. And this is straight out of 2005, where we've got an iPhone and a phone and an iPod as 2 separate items. So I'm going to label that phone, I'm going to label this iPod. Okay, now it says 22 carried a phone. This is really important. It doesn't mean that 22 goes here. It means that everything in this set here is going to add up to 22. So maybe you could just write that up here, 22, just to remind you that that's the case. 9 carried an iPod, same thing. Everything in the iPod set is going to have to add up to 9. Now 3 both carried a phone and an iPod, so 3 goes here, and 2 students carried neither, so 2 goes there. Right, now we've got to figure out the rest of it. So if the people that carried an iPod adds up to 9, we've got 9 people that carry an iPod, 3 happen to carry a phone, and then that leaves 6 that carry an iPod only. Over on the left here, 22 carry a phone, 3 happen to carry an iPod, which leaves us with 19 that carry just a phone. Now, a good way to check that you have got this right, all of everything that we've written down should add up to 30. So 19 plus 3 is 22. 22 add 6 is 28. Plus 2 gives us 30. So that's good. And we'll just do one of these probability questions, I think. Let's find the probability that they carry neither a phone nor an iPod. So we're looking for the amount of people that applies to, which would be these two people here that don't belong to either set, out of the 30 in total. I don't think we've made you simplify for this one. So 2 out of 30 is fine, or you can do 1 out of 15 if you prefer. Okay, now out of 50 desserts served at a restaurant one evening, we got, this is a two-way table question. So we can do something pretty similar for this one. We've got 50 desserts, so everything is going to add up to 50. 25 was served with ice cream, so the total of the ice cream row is going to have to add up to 25. Similarly, 21 was served with cream, so that's going to have to add up to 21, and 5 was served with both. Okay, so that's all the information that's given in the question, but that's actually enough for us to figure out what the answer, to fill out the table completely. So 5 plus something is going to give us 25, so that's got to be 20. 5 plus something gives us 21, so 16. 25 plus something is 50, so 25. 16 plus something is 25, so 9. 20 add 9 is 29, and then we'll just check 21 add 29 equals 50. So that works in every direction.
College. Make your way up to the staff room shortly, and please bring your device. Have a fabulous day.
Oh, time is officially running out. So how many of these desserts did not have, let's do a probability one. How many of these had only cream? Okay, so we've got to interpret it as they have cream, but not ice cream. So it's these specific 16 people here. So 16 out of 50. So think carefully about what the question is actually asking you. Okay, I've been summoned to the staff room, and oh, it's so close. It's so close. Do you know what I might do? Let's refer to the, I'm not going to draw this one, I'm going to have to just refer to the pre-existing solutions. I hope that's okay and that you forgive me, either in this life or the next. By the way, the solutions for every question is available. This was more just talking through what sort of thing you have to be able to do. Now, the last skill that you need to be able to demonstrate is providing a 5-number summary and then using that 5-number summary to create a box plot. Okay, the first thing you've got to do is put your data in order. So that's what I would have done here. You can cross off the data points as you go until you've got them in order. You can do that nice and slowly just to make sure you don't make any mistakes, or if you make one mistake, you can just do a fresh line underneath. Now, the 5-number summary is as follows. The smallest number is the minimum. The biggest number is the maximum. So they are the two easiest numbers to determine. The median, which is also sometimes known as quartile 3, but we know it as the median. That's the middle, quartile 2, I must say. Quartile 2 is the median. And that's the middle number when they are put in order. So let's just determine those ones real quick. Maximum, median, and the minimum as well. Now, the ones that are a little bit tricky are quartile 2 and quartile 3. The way that you think about these ones is that quartile 1 is in the middle of everything that's to the lower end of the median. So if we look to the left of the median and just look at these results to the left, we find the median of that, which would be 11. And that gives us quartile 1. Now, if we looked to everything to the right of the median, find the middle of that, that gives us quartile 3. And then when we draw our box plot, it looks a little bit like this. We've got our minimum down the end. We've got quartile 1. We've got the median / quartile 2. We've got quartile 3 and the maximum as well. And what it does, it shows us where the data is, like how spread out it is. Because those two, the interquartile range is going to show us where the middle 50% of the data is. And that's kind of the idea. You want about 25% of the data in each of those different quartiles. All right, so I'm going to go now to stop me from losing my my job and getting in trouble with the deputies. You've got any specific questions, make sure you get in touch with your teacher, but that's every skill that you need for the exam. Peace.